Okay, let's start with a mental image. I want you to imagine you're holding your phone, getting ready to take a selfie, but there's a catch.
Mm.
You're not in your bathroom. You're speeding through the universe at, let's say, 50% the speed of light. You're in this futuristic spaceship, and you're looking into a mirror that's moving right along with you. Maybe it's on the dashboard. You snap the picture. The question is, what do you see?
It sounds like a simple question, doesn't it? I mean, your intuition just tells you, I'd see my face. But if you ask Albert Einstein or, look at standard relativity, the answer is actually quite disturbing.
Disturbing how? Like I'm having a bad hair day.
Worse. According to standard physics, specifically this thing called length contraction, your reflection would be physically warped. It would be squished and
Yeah.
stretched into a shape that looks, and this is literal, like a banana.
The banana.
A banana. And the crucial point here, the really wild part, is that standard relativity claims this isn't a camera glitch. It claims that in that frame of reference, your face physically becomes that shape because
Yeah.
space itself is warped.
Wait, hold on. You're telling me standard physics argues that my actual skeletal structure, my bones, squash into a fruit shape just because I'm moving fast?
In the frame of reference of the camera, yes.
Yeah.
The reality of the object is relative to how it's observed.
Mhm.
The universe bends, so your face bends with it. That's been the textbook answer for 100 years.
That feels, well, it feels wrong. My face is solid and shouldn't care how fast I'm going. And this is exactly why today's deep dive is so fascinating. We have this stack of documents, technical papers, Python simulation code, even AI audit logs that completely challenge this. They call it the Zioned chat view.
That's right. And their counterclaim is, well, it's refreshing in its simplicity. They just say, no, your face is fine.
Okay.
That banana shape you see in the photo, it is purely an optical illusion caused by signal lag.
That's a massive shift. So basically, they're arguing that for a century, we've been confusing the map with the territory.
Precisely.
So our mission for this deep dive is to figure out, do we live in a bendy universe where faces turn into fruit, or are we just looking at a very, very laggy video feed?
To really get a handle on this, we have to start with a framework these sources lay out. They are incredibly strict about separating reality into what they call three worlds. They argue the reason physics is in this mess is because we've blurred the lines between them.
I saw that in the notes. It felt like they were laying down new laws before we even got started. So let's unpack these three worlds. World one is the math, right?
Correct. World one is a mathematical world. Pure logic, geometry, all the formulas, Lorentz transformations. It's perfect, it's abstract, it exists on paper. In world one, 1 + 1 always equals 2.
Okay, easy enough. Then there's world two.
World two is the physical territory. This is the electromagnetic field, what they call the medium. It's the objective reality where events actually happen.
So like the stage.
Think of it like a giant invisible ocean or a canvas. If a light flashes, it flashes at a specific coordinate in this medium. It's absolute. It doesn't care if you're watching it or not.
So world two is what's actually happening, regardless of who sees it, which brings us to world three.
Exactly. World three is the observational world. This is the map. It's all the data we collect via light signals. And here is the core problem that the sources highlight. Because light takes time to travel, the observational world is always old news. It's always delayed.
Right, and we know that. If I look at the sun, I'm seeing it as it was 8 minutes ago. That's not controversial.
It isn't. But the implications are where the controversy lies. The documents introduce a term for the error they think standard physics makes here. They call it description narcissism.
Description narcissism. Wow, that's a pretty heavy accusation to throw at Einstein. Are they saying he was, like, full of himself?
Not Einstein personally, but the perspective he codified. Think about it. When you see a clock moving away from you at high speed, it looks like it's ticking slower because the light from each tick takes longer to reach you.
Okay, makes sense.
So you have two choices here. Choice A, the clock is ticking normally, but the signal is lagging, creating an illusion of slowness. Or choice B, time itself is slowed down to accommodate my observation.
And standard relativity picks B.
Exactly. It centers the reality of the universe on the observer's experience. It assumes the universe has to bend to ensure the observer's measurement remains valid. It confuses the map, your delayed observation, with the territory, the actual clock.
It's like if I see my reflection in a funhouse mirror and I look all squiggly, description narcissism would be me panicking and calling a surgeon because I think my bones actually broke.
Precisely. You're mistaking the distortion of the medium for distortion of the object. The Zioned chat model is basically saying we've been panic dialing the surgeon for 100 years when we should have just realized the mirror is curved.
Okay, I get the philosophy, But physics isn't just philosophy, it's mechanics. To prove this, they can't just use metaphors. The documents describe a specific setup they call the realist setup.
Right. And this involves someone they call the boss.
I love that they call this observer the boss. It's great.
It fits. Imagine an absolute electromagnetic field. That's world 2. And imagine an observer, the boss, located way up high at coordinates, say 0, 0, 100. The boss is static relative to the field.
Okay.
Because the boss isn't moving and has this God's eye view, they can see events exactly where they happen. Once you correct for light travel time, the boss represents the truth of world 2.
So the boss sees the car moving, sees the face, sees the mirror. Now down on the ground inside the simulation, we have our moving car. How does light behave in this model? Because this is where I got a little hung up.
It boils down to what they call the pin analogy.
Okay, walk us through the pin.
Imagine a passenger on a moving train. They hold a pin out the window and drop it. Now, does the pin stay with the train?
Well, technically, if we ignore air resistance, the pin has the forward momentum of the train. So it would travel forward alongside the train as it falls, right? Inertia.
In Newtonian physics with matter, yes. But here's the crucial distinction the source material makes. Light is not matter. They argue that once a photon is emitted, once the flash happens, it does not carry the source's momentum in the same way.
Wait, so they're saying light doesn't have inertia?
They're saying the emission event is pinned to the coordinate in the medium where it happened. Think of the medium like a train track. If you drop a paintball onto the track, the mark stays on the track. The train moves on.
So if I flash a light in my car, that flash is stuck at that specific mile marker on the highway.
Precisely. The flash stays at mile marker 50. Your car moves on to mile marker 51. You are literally driving away from the light you just created.
That is a huge difference. You leave the origin point behind.
You leave it behind. And this creates what they call a point cloud of events. Instead of seeing a continuous moving object, reality, as far as light is concerned, is a series of dots left behind in the medium.
Okay, I'm visualizing this. I'm in the car, speeding at half light speed. The mirror is moving with me. Standard intuition says I am moving, mirror is moving, it cancels out. But if I'm leaving the light behind at a specific mile marker,
Then you have to deal with what they call deviation shooting.
that sounds like a sniper tactic.
It's just geometry. Think about it. Light leaves your nose. It aims for the mirror on the dashboard, but the mirror is moving at 50% the speed of light. If the light aims for where the mirror is when it leaves your face, it's going to miss.
Oh, right.
The mirror will have moved forward by the time the light gets there.
Because the light takes time to travel, and the mirror is just booking it down the highway.
Exactly. So for the reflection to happen at all, the light has to angle forward. It has to chase the mirror. It takes a diagonal path through space.
And once it hits the mirror?
It bounces.
Yeah.
But now it has to hit the camera lens, and the camera has also moved forward, so the light has to chase the camera now.
So instead of a straight line back and forth, like we all assume, the light is doing this long, stretched out zigzag through space.
Exactly. And that zigzag is the key to the banana face.
I still don't see how a zigzag turns my face into a fruit. Just because the path is long, why does that warp the image?
It's all about differential delay. Think about the shape of your face. Your nose is physically closer to the dashboard mirror than your ears are.
All right.
Even if it's just by a few inches.
Sure. Yeah.
Because of that zigzag path and the extreme speed, light from your ear has to travel a slightly different, longer distance than light from your nose. It has a longer path to chase down the mirror and then come back to the camera.
Okay, so the light from my ear arrives at the camera later.
It arrives at the camera at the same time when the shutter clicks. But, and this is the key, it didn't leave your face at the same time.
Oh, okay, wait, I see where you're going.
The camera is stitching together a mosaic. It's capturing light that left your nose, say, 1 second ago, but it's also capturing light that left your ear maybe 1.2 seconds ago.
And because the car is moving at half the speed of light, 1.0 seconds ago and 1.2 seconds ago are two completely different locations in physical space.
That is the aha moment. The camera is taking a slice of your nose from mile marker 100 and a slice of your ear from mile marker 95 and combining them into a single image. This smears the image across space. It creates that curved, banana-like appearance.
So the photo will show a banana. The sources agree on that part.
Yes, the observation world 3 is warped, no question. But the Zionad chat model insists that in world 2, the physical territory, your face remained perfectly round the whole time. The data retrieval was curved, not the object.
It's like taking one of those panoramic photos on your phone and the subject moves halfway through. The person looks all distorted, but you don't assume they actually melted. You just assume the camera process was slow.
Precisely. And what's so fascinating is that they didn't just theorize this. The sources talk about a banana face relativity simulator that they wrote in Python.
I saw the references to the code. It uses something called reverse ray tracing. But how does that prove anything? I mean, anyone can write code to spit out a result they want.
True, but reverse ray tracing is mathematically rigorous. It starts at the camera pixel and works backward in time to find out where the light originated in the medium. And the simulation produces this very specific visual they call ghost rings.
Ghost rings. Okay, explain that.
The simulation renders two things on the screen at the same time. First, a pink ring, that's the distorted banana shape, it's what the camera sees, but overlaid on it is a blue ghost ring.
And the blue ring is?
The blue ghost ring represents the actual circular position of the object in the medium at that exact moment. And the simulation shows them both at once. The pink ring is a warped mess. The blue ring is a perfect circle.
So the code visually proves that you can get the distortion, the kink ring, purely from the signal lag without ever actually warping the object, the blue ring.
It proves the distortion is an artifact of the viewing method, not a change in the object's reality.
That is incredible. But, you know, we live in the era of AI. And what I found really compelling was the audit section. They didn't just publish this on a blog. They submitted the logic to AI auditors, specifically Gemini and Claude.
Yes, and this wasn't a casual chat. They gave the AI a really specific prompt. Don't just recite Einstein to us. Audit this logic. Check the consistency of the World 2 premise.
Because usually if you ask an AI about relativity, it just regurgitates the textbook.
Right. But when they forced it to audit the internal logic of this specific absolute medium model, the verdict was striking. The AIs deemed the logic logically complete, and Gemini specifically used the word revolutionary to describe the perspective.
Revolutionary, that is not a word you throw around lightly in physics.
No. And the key takeaway from the audit was that if you accept the premise, if you accept that there is an absolute medium, a world 2, then the paradoxes of relativity just disappear. You can explain the banana face completely through optical lag. You don't need to warp space-time.
It feels like a relief, honestly. Like, oh, the universe isn't broken, my camera is just slow, but I have to play devil's advocate here. Standard relativity isn't just a theory, it runs our world. GPS satellites rely on relativistic corrections to work. If this new model says relativity is narcissism, why does my GPS still get me to Starbucks?
That is the big question. And the source material addresses this brilliantly in the section on the politics of physics. They compare inertial frames to nation-states.
I skimmed that part, but it seemed like a strange leap. What do countries have to do with physics?
It's a metaphor for standardization. Think about a time zone. In reality, the sun is in a slightly different position over Chicago than it is over Detroit. Ideally, Detroit should be a few minutes ahead.
Well, we force them to be the same time so the trains run on schedule.
Exactly. We create a democracy of time. We average out the messy reality to make the trains run on schedule. The source argues relativity does the exact same thing. It forces all the photons in a frame to agree on a simultaneous now, even if they have vastly different travel histories.
So an inertial frame is just a time zone for physics.
Yes. And just like a time zone, it works for logistics, like GPS, but it isn't true to the local reality. The host in the source material makes a great point here. They argue that by smoothing out the data, we commit the destruction of physical quantities.
The destruction of physical quantities, that sounds intense.
It means we delete the individual history of each photon. In the real world, in World 2, every photon has a specific travel time. Some took longer, some took shorter because of that zigzag we talked about. But the standard model just averages that out to make the math look nice.
So we're trading truth for pretty math.
And for convenience.
Yeah.
GPS works because the math is internally consistent for prediction. It's a perfect map. But the cost is that when you refuse to admit that some citizens, some pixels or photons receive the news later than others, you have to force the model to warp time itself to maintain the democracy.
It's like, if I receive a letter a week late, and instead of admitting the mail is slow, the government declares that time traveled backward for me just so I received it on time.
That is a surprisingly accurate analogy for how relativity handles simultaneity. It bends the timeline to save the synchronization.
So this Zionad chat view flips the whole script.
It flips the direction. Standard relativity is inside out. It builds the universe from the limited, laggy perspective of the observer. It's like a hiker trying to draw a map of the mountain while standing on the ground. Everything looks distorted by their perspective.
And the new model.
The new model is outside in. It builds from the objective reality of the medium from World 2. It's the satellite view. The satellite sees the mountain as it actually is, not just how it looks from the ground.
The satellite view doesn't care if the hiker thinks the path is steep or curved. The path is the path.
Exactly.
It's a lot to process. We're effectively moving from a model where the universe bends around the observer, which is that description narcissism, to one where the universe is solid and the observer is just holding a slow camera. That's realism.
And it suggests that relativity's math might just be a really good formula for a funhouse mirror. It's perfect at predicting the distortion. If you want to know what the photo will look like, use relativity. But it fails to describe the underlying bones of the universe.
It works for the map, but not the territory.
Correct.
So what does this mean for us, for the listener? I mean, most of us aren't traveling at 50% light speed taking selfies.
True. But it changes how we think about information. We're used to thinking that what we see is what is real. But this reminds us that everything we experience is World 3. It's all a reconstruction. It's all delayed.
It's a reminder to be humble about our perspective. Just because I see a banana doesn't mean it is a banana.
And it raises the question, what other paradoxes in science are just us confusing the map for the territory? If we stop trying to force the universe to fit our observation and instead correct our observation to fit the universe, what else might become simple?
That is a tantalizing thought.
Yeah.
Maybe quantum mechanics is next on the chopping block.
One revolution at a time. But I do want to leave the listener with the final question posed by the source material. It's a bit of a provocation.
Let's hear it.
If you look in a mirror and see your reflection squashed, do you rush to the hospital for bone surgery? That's space-time warping. Or do you just realize the mirror is curved? That's optical physics.
And we might have been performing space-time surgery for 100 years when all we needed was a better understanding of optics.
I might have been.
That is something to chew on. Check your mirrors, folks. And don't trust the lag. Thanks for diving in with us.
Until next time.